a mother duck. Now, I've been teaching at this school for many years now, and I have never seen anything quite like this. When Mr. May had that collarbone incident when he was riding his mountain bike, he wanted me to come in and teach this class. And I told him I'd rather set myself on fire. But I did it anyway, and I've been giving 120% every day teaching you pugmuckers how to optimize. But I guess that's not how it's working out. Now, who got the 32%? For Pete's Peppers, son! This is not how you take the derivative. You took the integral. What are you doing?
I'm sorry.
It better not happen again. Alright, guys. Today, I'm teaching you how to optimize. And you better listen, or I will set you all on fire. This is how you do it. Alright, so, optimization. Let's see here. There's a triangle. Make the triangle. It's a right triangle, by the way. That's very important. There's an X and Y, hip to dip.
Wait.
Then there's 20 coming across the hypotenuse right here. Then it goes 1/2. Columbus! Turn that cell phone off right now. You've got to be kidding me! Columbus, give me that cell phone. What even is this? What is this? What is this?
Call me maybe.
Call me maybe? For Pete's Peppers, son! Back in my day, we listened to good music. Led Zeppelin, the Beatles. I'm sick of it! Caprice, stop dancing around like a little fantasy fairy or whatever you guys like these days. I don't even know what this is. I'm already sick of it. I'm teaching a class I don't even care about. Oh, I'm sick of it!
Sorry, Mr.
Alright, so back to my
happened again?
science lesson. Yeah, you two better be sorry. Science.
What,
Alright, let's do this. Okay, so back to what I was saying. There's an X, and the formula is, so then you find the distance traveled, and then plug it into the formula, which is the dx.
Mr. Hines?
What do you want, Columbus? I'm teaching a science lesson.
Sorry for interrupting, but when are we going to use this in real life?
Well, I don't know. Want me to show you a video or something?
Yeah.
Alright, let's show it then.
Optimization is the process of finding the greatest or least value of a function for some constraint, which must be true regardless of the solution. In other words, optimization finds the most suitable value for a function within a given domain. This process is commonly used in computer science and physics, often called energy optimization. The three general ways of optimizing a function are: find the absolute extrema of the function, use the first derivative test, or lastly, the second derivative test. And now we cut to my partner, Seductive Bob.
Hi, I'm Seductive Bob. How you doing on this fine dandy day? Anyways, back to optimization. Where did I leave off? Okay, so here we have a picture of basically a core, which is represented right here. And so we have a 1-inch margin here, a 1-inch margin here, 1 inch here, and 2 inches on the top, which represents like the top of the actual core. And for this part, we're trying to find the max dimensions that will give this shape the most area. So if we had 180 square inches for this total area, and if we had 180 inches for this total area, we're trying to find out what would be the max dimension. So we're going to try and say the area is equal to x times y. And this would be x, and this would be y. And for this, we're going to do, since these sides are both 1 inch, we're going to do, here, let me erase first. So the area of the shape is XA equals X times Y. And so to find this area, we're going to do X minus 2 times Y minus 3. And this is because the dimensions of the top, there's 2 inches, 2-inch margin on the top, and a 1 inch on the bottom, so that's 3, and then 2, so 1 on each side. And so what we're going to do is we're going to try and set this equal to, we're going to solve for y here. So since x times y equals 180, 180 equals x times y, we're going to set y equal to 180 over x. So we're going to set this whole thing, or we're going to plug y in. So it's going to be a of x equals x minus 2 times 180 over x minus 3. And now we're going to multiply this out, and you get a of x equals, so it goes to balls. Wait, baseballs, that is, kids, baseballs. So we have this, and we're going to multiply this all out, so you get 180 minus 3x minus 360 over x plus 6. And so the next step, we're going to solve for the derivative. So it's going to be the derivative of this, which is negative 3 minus, or plus 360 over x squared. And now you're going to set this equal to 0, and x comes out to be 10.954. So to solve for y, you're going to plug this in to this equation and have the area be 180. So you're going to have 180 equals 10.954y. And y comes out to be 16.432. So the dimensions will be 10.954 by 16.432 for the max dimensions of 180 square foot cooler, basically. And this has been another lesson with Seductive Bob.
Alright, I hope you found that video very insightful. Now I'm going to go into more depth and try and get a better understanding of what optimization is. Alright, let's do this. Here we go. So, again, you want to draw the triangle and then the x and y axis. So here's the y, the x, the skip-diddly-diddly-do, the 20 across the hypotenuse.
Mr. Hines, what are you doing? You have no idea what you're teaching. I like Seductive Bob way better. He actually knows what he's talking about. Can you teach us something that you actually know?
Son of a mother's lover. Columnist, I dream of the day when neuroscience allows me to get shrunken into a bite-sized pea. From there, I will take a submarine and be injected into your spinal fluid. From there, I will travel up into your brain meat. And once I am there, I will take a pill that allows me to grow back to normal size, exploding your skull bone and rendering your body into a pink mist. Now, Columns, why don't you teach this since you're so knowledgeable? Hines out.